Hi. Okay, we're back with lesson 16, which is on applications of vertex form. So it's just a continuation from Monday. We're gonna go over Monday again, 2 examples, and then we're gonna do some word problems as well. So our learning goal is to learn to solve word problems that involve quadratic functions by using a variety of methods. If a question involves maximum or minimum, we know that it has to be put into vertex form. We must identify whether you're given an input or an output, and it's often helpful to sketch a graph and label an axis in a word problem. We went over that Monday as well. So just to recap then from Monday, determine the exact coordinates of the vertex of each quadratic function, state the maximum or minimum value of each quadratic function. So this quadratic function is given to us in standard form, and that's the form you remember. Y equals ax squared plus bx plus c. And we want to change it to vertex form because it's asking us for the exact coordinates of the vertex. And if we get it into vertex form, we know the vertex will be at the coordinates hk. So because a is a negative number, we know that this quadratic function is going to have a maximum because our parabola is going to be opening downward. It's going to have a highest value. And to find that, we need to put it into vertex form. So first we need to factor the step number a out of the terms containing x. So negative 1/6 x squared divided by negative 1/6 is just x squared. And then again, hopefully you're getting good at this now. We have to do 3x divided by negative 1/6. To divide by a fraction, you multiply by the reciprocal. I guess it's x there. So that's going to give us negative 18x. Close my parentheses, plus 2. Okay, again, these are equivalent representations. All I did was factor the step number out of the terms containing x, and if I wanted to expand using the distributive property, I would just get right back to there. So we haven't changed anything. So now inside the parentheses, we want to complete the square so we can get the x part of the vertex. So to complete the square, that's where we take half of 18, which is 9, and square it, which is 81. We're going to add 81. But we also have to subtract 81 so that we're just really adding 0 and not affecting the equivalence. But then we've created this perfect square trinomial through completing the square that we can factor. So that's going to factor this part to give us x. The sign from the middle term minus square root of 81 is 9, all squared. That keeps it a quadratic. And then we have to get the negative 81 out of the parentheses by multiplying it by negative 1/6. So negative 1/6 times negative 81. So again, if we that fraction button we looked at here, I could do negative 1/6 times negative 81, and it gives me, now see that says 13 1/2, but if you want to change that to an improper fraction, you can just, well, you could write 13.5 as a decimal, but you can also do shift and press the fraction button again, and it gives it to you as an improper fraction, 27/2. So plus 27/2, and then plus 2, but we want to add 2 with a common denominator of 2. So that's going to be plus 31/2. So the exact coordinates of our vertex are going to be 9, 31/2. And we have a maximum, which is 31/2, which is exactly 15.5. So there's our maximum value. Okay. And then our second type here, this is where We don't start with a being a fraction, but we create a fraction when we factor the a value out. So we want to factor the a value out of the terms containing x. 3x squared divided by 3 is x squared. And then thinking of 5x divided by 3, but writing it as 5/3 x. Close your parentheses, and then minus 1. And we know because this is a positive 3 that it's going to open upwards, so this one's going to have a minimum that we can find. Okay, so now we have to take half of 5/3 and square it. So I'm thinking to myself, to complete the square, I need a number in here, and that number is half of 5/3 squared. So half of 5/3, you could do 5/3 divided by 2, or 1/2 times 5/3. That's going to give you 5/6, but we want to square that. 5/6 squared. So that's going to be 5 squared over 6 squared, or 25 over 36. But we also need to subtract 25 over 36, so that we're really just adding 0, changing what it looks like, not its value. Factor the perfect square trinomial, so it's going to be x plus the square root of 25 over 36, which is 5/6. So you can square root the top and square root the bottom, squared. Then we have to get the negative 25 over 36 out of the parentheses by multiplying by 3. 3 times negative 25 over 36. Gives you negative 75 over 36, but that reduces. You can divide top and bottom by 3. So that reduces to give you negative 25 over 12. So negative 25 over 12. But then we want to subtract 1, but we need a common denominator. So we can change 1 into 12 over 12. So 25, so that's going to be minus 37 over 12. So our vertex, the exact vertex, is going to be at negative 5/6. Be careful there. Negative 37 over 12. And we said at the beginning we'd have a minimum because the a value is positive, and our minimum value is going to be negative 37 over 12. Okay, so that's kind of a recap of Monday. So now we're going to do 2 word problems. We did 1 or 2 on Monday as well, I think. And then that'll be kind of this week's chunk of information that I want everyone to understand, and a little evaluation will be coming tomorrow. Okay, so a ball is launched from the roof of a house. The height of the ball above the ground is given by the function h at t is negative 16t squared plus 48t plus 100. Then it says where t is greater than or equal to 0, t being time, so that makes sense, where h represents the height in feet and t represents the time in seconds. So how tall is the house? Okay, so let's do a little sketch then. So we have a ball launched from the roof of the house. So let's say here's the roof of the house. We're not sure where that is. And it's going to go up like a parabola because we can see that it's a quadratic with a negative. So it's going to have a maximum value and then come back and hit the ground. So this is going to be its height at time t. And this is going to be the time. And the height is measured in feet. And time is in seconds. So this is asking, where does it start from? So how tall is the house? So you've got to think to yourself, well, when you throw the ball off the roof, that's when time is 0. So it's actually asking what is h at 0. So that means you can use the quadratic given to you and just replace time with 0. And you can see multiplying by 0 just gives you 0, so you're going to end up with h at 0 being 100. So that means that, therefore, the house is 100 feet tall. Part B asks what the maximum height is. So this is 100 feet here. And we want to know how high up do we throw the ball off the roof of the house. So when we see that word maximum, we know that we have to put it into vertex form. So my h at t, the a value is -16. So I'm going to factor that out of the terms containing t. So that's going to give me t squared. And then if you look back up here, which you guys can see, 48t divided by -16 is -3t. Close my parentheses, plus 100. So now we want to complete the square inside the parentheses here. So we want to take half of 3. So a lot of us know that in our head. Half of 3 is equal to 1.5. Okay. In a word problem, we can use decimals, especially if they're perfect decimals like this, but then we want to take half of 3 and square it. So 1.5 squared is 2.25. So to complete the square, we're going to add 2.25, but then to keep it balanced, we subtract 2.25 as well. Close the parentheses at 100. That's our perfect square trinomial. So it's going to be t minus the square root of 2.25 is 1.5 squared. But then we want the negative 2.25 to come out of the parentheses, so it has to be multiplied by -16. So I'm going to do that on my calculator. -16 times -2.25 turns out to be positive 36. Which makes h at t equal to -16 times t minus 1.5 squared plus 136. So therefore the maximum height of the ball is 136 feet. So that's how high it gets off above the ground. C says, how long after the ball is launched does it reach its maximum height? So what time is it when it reaches that height of 136 feet? Well, this vertex here has the coordinates 1.5, 136, that's HK. So that means the ball reaches its max height at 1.5 seconds after you throw it. Okay, and then how long is the ball in the air? So let's go back to the picture. Oh, you can see it, it's up here. So how long is the ball in the air? So you're on the roof of your house, you throw the ball, it goes up to its maximum, then it comes down, and eventually at some time it's going to hit the ground, and that's the time we want to know. So they're actually giving us, or they're inferring to us that they want the time when h at t, the height of the ball above the ground, is equal to 0. So if we start off with this premise that h at t has to equal 0, we've been given two formats for h at t. We've been given the standard format in the original question, but then we took the time to change it into vertex form here. And if you use the vertex form for h at t, t is only in one position, so you can use reverse BEDMAS to solve the quadratic equation rather than using the quadratic formula. If you use the standard form, you could use the quadratic formula. So if you really like quadratic formula, you are welcome to do that as well. I'm going to use reverse BEDMAS since we already went through the trouble of putting it in vertex form. So reverse BEDMAS, to isolate t, we would subtract 136 on both sides first. Then divide both sides by -16 next. So -136 divided by -16 is 8.5. Square root, don't forget plus or minus on this side. So t minus 1.5, so square root undoes squared, equals plus or minus. And I'm going to check whether that's a perfect square or not. It's not, so we'll just leave it as plus or minus 8.5 and let the calculator do the work for us in a minute. Okay, so still trying to get t by itself using reverse BEDMAS. So I have to finally add 1.5 to both sides. That if we go over here, because I'm running out of room, we get two possible solutions. Either t is 1.5 plus the square root of 8.5, or t is 1.5 minus the square root of 8.5. And use our calculator here. So 1.5, in case you want to see me typing it in here, plus square root of 8.5 equals approximately 4.4. And then from this one, 1.5 minus the square root of 8.5, negative 1.4 seconds, which we would call inadmissible because time has to be greater than 0. Okay, so then we can answer the question, how long is the ball in the air? Therefore, the ball is in the air for 4.4 seconds. Okay, so that's a typical max word problem with a little bit of extra added on as well. We talked about figuring out how tall the house was originally by realizing that that was when the time was 0, and also how long the ball was in the air by realizing the hidden clue there was that the height was 0. Okay, here's another word problem. So we have a lighting fixture manufacturer has daily production costs of C equals 1/5 n squared minus 8n plus 660, where C is the total daily cost in dollars and n is the number of light fixtures produced. How many fixtures should be produced to yield a minimum cost? So we see that word minimum and we know we have to change it so that it's in vertex form. So that's what we'll do here. So that means we're going to have to common factor the step number 1/5 out of the terms containing n in this case. So n squared minus, so I'm thinking I have to divide 8n by 1/5, which is like multiplying by 5. So you multiply by the reciprocal. So that's minus 40n. Close your parentheses, plus 660. So to complete the square, we have to take half of 40, which is 20, and square it. And 20 squared is 400. So we add 400, subtract 400 to keep it balanced, add 660. Factor the perfect square trinomial. So that's going to give me n minus the square root of 400 is 20 all squared. Then to get the negative 400 out of the parentheses, you want to multiply by negative 400. So we can do 1/5 times negative 400 is negative 400 over 5. Which is negative 80. And C is 1/5 and minus 20 squared. And then negative 80 plus 660 is positive 580. Then reread the question to make sure that we're going to answer it correctly. How many fixtures should be produced? So here's where a picture is good to make sure that you've answered correctly. So we'll do a little sketch here. So in this case, we know we have a minimum, and we know that C, or cost, is going to be on our vertical axis, and N, which is number of fixtures, is going to be on our horizontal axis, and we know we have a minimum, and that our minimum cost is 580 when our number of fixtures is 20. So the answer to the question, how many fixtures should be produced, is therefore 20 fixtures should be produced to minimize cost. Part B, what is the daily cost when 27 light fixtures are produced? Okay, so that's telling us that N is 27, and it's asking us what is C. So we can substitute into either of our formats. So I've substituted into standard form before, so I'll do the Vertex form this time, just to show you that it doesn't matter. So N is 27 minus 20 squared plus 580. So it's going to be it's going to be 1/5 times 49 plus 580. Divided by 5 is 9.8, plus 580 is 589.80. So therefore, daily cost is $589.80. And it makes sense that is bigger than 580 because 580 is the minimum. So any other number of fixtures other than 20 is going to be higher daily cost here. And then part C, how many light fixtures are produced if the daily cost is 630? So in this case, they're telling us that C is 630. And they're asking us what N goes with C being 630. So 580 is here, if we go back up to our graph. So 630 is going to be above it. So it looks like we should get two different values of N that would give us a daily cost of 630. Okay? The only one that just has one corresponding is the vertex. Okay? All right, so we can use either form again. I'm going to use vertex form, and I'm going to say starting with C equals 630, but then I can replace C with the vertex form, which is 1/5 N minus 20 squared plus 580. And then use reverse BEDMAS. So I'm going to subtract 580 on both sides. Oh, sorry, 630 minus 580 is 50. And then undoing multiplying by 1/5, I could just multiply by 5, because 5 times 1/5 is 1. So 50 times 5 is going to give me 250. Then I want to square root both sides. So then I get n minus 20 equals positive or negative the square root of 250, which isn't perfect, so we'll leave it. Add 20. And then it can break into two possibilities. One is going to be that n is 20 plus the square root of 250. And the other one will be that n is 20 minus the square root of 250. Then we'll use our calculator. So that to the nearest light fixture, 35.8, let's say approximately 36. And then this one, 20 minus the square root of 250, 4.1, so approximately 4. And so what that means that this is 4 and this is 36. Okay, so it makes sense to have two possibilities. So therefore, either 4 or 36 light fixtures will have a daily cost of $630. Okay, a lot of people ask, how can there be two possibilities? So if this is being modeled by a quadratic, there will be two possibilities if you're other than the vertex. So you might think, well, why does 36 cost just as much as 4? Well, maybe you have to hire more workers, and then there's lots of factors that you can take into consideration. All right, so success criteria for this lesson then are knowing that if the question asks for a maximum or minimum and it's a quadratic function, you have to put it in vertex form and make sure you can do that accurately. The vertex is identified and a rough graph is sketched and labeled that can really help you answer the question that's being asked. Okay, so and then the question asked is being answered correctly. And then the information given in the problem, you've identified it correctly as being an input, something you put into the function, or an output, what the function is, and then you solve for the other value using reverse BEDMAS is the way we've done it in this lesson. Okay.